Mina, this experiment is going to be an underwater volcano eruption. So we just mixed some baking soda with water, and then we put vegetable oil on top. Steffo, are you ready to watch the experiment?
Yeah.
This is going to be neat. Look at the test tube on the table. Can you see the test tube?
We put some oil in it.
Okay, we're going to count down to 3. And I want you to put the scoop in there when we count to 3, okay? 1, 2, 3. Go ahead. Okay, watch. Do you see? What's going to happen?
It's turning red.
It's turning red as it's dropping. Can you tap it a little bit to help it go down a little bit into the volcano? Because the blue is the volcano. It's stuck in the oil. So there's vegetable oil on the top, and that's sealing the volcano under the... Stand it all the way up. Here we go. Okay, move your hand. Move your hand. Whoa! What's happening? It's erupting. So each one of those bubbles is a little bit of carbon dioxide exploding out of this volcano. Do you see that?
Is it really going to do it?
Look, it's exploding. Do you see that exploding? It's a micro explosion, but it is an explosion. And it's all happening underwater.
Is it going to really explode?
Well, explosions are all relative. So this is a small explosion. If we did this on a big scale, yes, we could have a huge explosion that would, like, you know, blow up a car or a house. And use different chemical compositions. Wow, look at that. Isn't that cool?
It almost went up to here.
It could still come up to there.
Whoa.
Whoa. Look at that. And it's still exploding. So is that an explosion to you?
Yeah.
So remember, each bubble is an eruption of carbon dioxide. When the citric acid mixes with the baking soda, and then we put the cabbage powder, the red cabbage powder in there to turn it blue, and when they're neutralized, they turn that pinkish red.
Cool.
And see, it's still clumping. So
look how much purple there is in there.
So what happened when you poured the vegetable oil in the test tube? Did it mix with the water? Did it sit on the top or go to the bottom?
It sat on the top.
It sat on the top because the oil is lighter than the water. And they don't mix together because their densities differ. So
I hope it doesn't explode in my face.
So the oil is less dense than the water. So when you added the citric acid, it sank to the bottom because it was more dense than the oil and the water. And then what happened when it touched the baking soda? Can you remember? Did it just sit there, or did it cause an explosion?
It caused an explosion.
Which was a chemical reaction, and it released what? Do you remember which gas it released?
Chemical?
Which gas did it release? Did it release oxygen or carbon dioxide?
Carbon dioxide.
Very good. And so some of the bubbles attached to the droplets of the colored water, and it carried them up to the surface of the oil. At the surface, the bubbles pop and the water droplets sink back to the bottom. So then that's when they react again and they become more neutral and it changes to purple. And as it continues to react, or we add more citric acid, it'll become more red. So you want to put another scoop of citric acid?
Where's citric acid?
And to your left.
Here?
Very good. Put another scoop in there. Okay, set it down, set it down. It's reacting.
Wow, look at that purple.
And as it turning more red, as it's becoming more neutral?
Look at the purple. It's going down. It's going to come on.
That is so Cool.
What if it doesn't in your face?
Nah, at this point, we're not using enough chemical to harm you because these are household chemicals. We use baking soda in cooking and cleaning, and we use citric acid. We drink citric acid every day in our juices, and we use it to help with some of our cleaning solutions as well. So at this level, it's harmless. It's not at super high concentrations mixed with other toxic chemicals.
Can I put some more?
Sure, go ahead, keep going. Keep going until the whole underwater volcano turns red. That's when it's been neutralized and there will not be any more reactions. Okay, wait. You gotta wait till it continues to react. Because remember, there's still clumps that are dropping down, right? Is it almost completely red? See how it's not erupting much anymore? Here, set it upright. Hold it upright. Can you use your left hand, please?
Left hand to do this.
Can you use your left hand to hold it so I can see? And then swirl it around a little bit. And I think it might be neutral at this point. What do you think? Because it's pretty red all the way through. Do you see that?
Mm-hmm.
There's still some of a chemical reaction because you can still see bubbles coming out.
Mm-hmm.
And you know that it's neutral when there are no more bubbles. There's no more gas.
Just like with those ones, there were bubbles, so there were gas.
That's right. It was releasing a gas. All right. So what's your name?
Mina?
Mina who?
Karis.
And what did you do today?
Did the science experiment.
Okay. Bye-bye.
Bye-bye.